Hello there, and welcome to the Sleepy Phantom, a quiet space where the universe whispers its deepest secrets just as you close your eyes. As you get comfortable and let the rush of the day dissolve into the night, tonight we will be exploring the profound and silent depths of the cosmos, carefully deconstructing the anatomy of a black hole. Before we begin our descent, it would be lovely to know where you are watching from. The Phantom travels to so many different corners of the world, and it is always comforting to imagine the peaceful rooms these quiet journeys reach. If you enjoy these gentle explorations into the edges of reality and want to support the channel, a like and a subscribe help more than you might expect. And to those who have already invited the Phantom into their evenings, thank you so much for returning. Please consider tapping the notification bell as well, so you do not miss our next voyage. And if the mysteries of the void turn out to be just a little too captivating, keeping you awake for a moment longer than planned, at least you will drift off having learned something beautiful about the dark. No rush, no noise, just knowledge, gently dissolving into dreams. Consider, for a moment, the absolute and profound stillness that exists just beyond the fragile, glowing veil of our atmosphere. The universe is not a canvas of chaos, but rather a meticulously ordered expanse of silence, governed by an elegant and unseen geometry. We are suspended in a fathomless ocean of space, a theater of cosmic mechanics that operates on temescals so vast they render our daily anxieties entirely inconsequential. In the deep, unending dark between the galaxies, there is a quiet inevitability to all things. Matter interacts with gravity. Light traverses the vacuum, carrying the ancient memory of long-dead stars. And within this serene, mathematical architecture, there exist phenomena that challenge the very limits of human comprehension. Phenomena where the fabric of reality itself folds, warps, and finally ceases to be. Tonight, we are going to explore the most misunderstood and elegantly terrifying structures in the known universe. We are going to deconstruct the anatomy of a black hole. To understand the nature of such a profound celestial object, we must first acclimatize our minds to the true scale of the cosmos. When we step outside on a clear, cloudless evening and cast our gaze upward, we are not looking at the universe as it is right now. We are looking deep into a deeply stratified archive of cosmic history. Light, for all its immense speed, takes time to cross the unfathomable distances of the interstellar void. The soft luminescence of the nearest stars left its source years ago. The faint, dusty glow of the Andromeda galaxy, visible only in the darkest of skies, is composed of photons that began their journey over 2 million years ago, long before the earliest echoes of human civilization. We are always inextricably observing the past. As we drift further outward, moving past the local group of galaxies, the distances become so expansive that our standard units of measurement lose their utility. We begin to measure the universe in light years, parsecs, on megaparsecs. Space is not empty. It is a continuously undulating tapestry, a four-dimensional manifold of space and time woven together. This fabric is pliant. It yields to mass. The larger the mass, the deeper the indentation it creates in this cosmic fabric, dictating the powers of planets, stars, and even light itself. This is the essence of gravity. It is not merely a force pulling objects together, but a curvature in the very environment in which they exist. To find the origins of our subject, we must seek out the most massive indentations in this local tapestry. We must look to the giants, deep within the nebulous stellar nurseries of the cosmos, where clouds of primordial hydrogen and helium slowly coalesce under their own subtle gravity. Stars are born. The majority of these stars are much like our own sun, modest, steady, and destined for a long, quiet existence. But occasionally, A star is forged with amassed ends, perhaps hundreds of times greater than our local star. These are the blue giants, the hypergiants. They burn with a ferocity that defies description, consuming their nuclear fuel at a staggering, accelerated rate. For millions of years, a massive star exists in a state of delicate, beautiful equilibrium. It is a constant, epic struggle between two opposing forces of nature. In the core of the star, nuclear fusion rages. Atoms of hydrogen are crushed together to form helium, releasing an immense outward pressure. This radiant energy pushes violently outward, seeking to tear the star apart, but pulling back inward with equal and unyielding strength is the star's own gravity. This balance, known as hydrostatic equilibrium, is what keeps a star stable and luminous. It is a perfect, violent harmony locked in the vacuum of space. But this harmony is not eternal. The fuel is finite. As the millions of years pass, the star exhausts its reserves of hydrogen. The core contracts, growing hotter and denser, initiating the fusion of heavier and heavier elements. Helium fuses into carbon, carbon into oxygen, oxygen into neon, and so on, moving methodically down the periodic table. The core becomes a layered concentric sphere, like a cosmic onion, with each layer burning a different element. Eventually, the core synthesizes iron. Iron is the celestial tipping point. The fusion of iron, unlike all the elements before it, does not release energy. It absorbs it. The delicate equilibrium that has sustained the star for millions of years is suddenly, catastrophically broken. The outward pressure of nuclear fusion ceases entirely in the core. The balance is lost. With nothing left to push outward, the total, accumulated mass of the star's outer layers comes crashing down inward, driven by gravity. The collapse happens in a fraction of a second. The outer layers rush toward the core at an appreciable fraction of the speed of light, rebound off the incredibly dense iron center, and are blasted outward in one of the most energetic events in the universe, a supernova. While the outer envelope of the star is expelled into the cosmos, enriching the interstellar medium with heavy elements, we must turn our attention to what remains behind, the core. If this remaining core possesses a mass greater than what is known as the Tolman-Oppenheimer-Volkoff limit, approximately 2 to 3 times the mass of our Sun, there is no physical force known in the universe that can hold its continued collapse. Not the repulsion of electrons, not the strong nuclear force holding neutrons apart. Gravity becomes the absolute and undisputed victor. The core continues to crush inward on itself. It shrinks from the size of a planet to the size of a city to the size of a grain of sand. And then, further still, the matter is compressed so infinitely that the mathematical equations we use to describe reality begin to break down. The curvature of space-time around this collapsing point becomes steeper and steeper, a deepening well in the fabric of the universe from which nothing can climb out. We have now arrived at the creation of a black hole. It is crucial to understand that a black hole is not a vacuum cleaner. It does not actively hunt or suck in surrounding matter with malicious intent. It is simply a region of space where the concentration of mass is so extreme that the local gravity has overwhelmed all other forces. If we were to replace our Sun with a black hole of the exact same mass, the planets would not suddenly be pulled into the abyss. The Earth would continue to orbit in its exact current trajectory. The only difference would be the sudden, permanent onset of a freezing, unending night. Black holes are elegant, silent custodians of mass, holding their position in the galactic geometry. As we drift closer to this profound object, the first anatomical feature we must identify is not a physical surface, but a threshold. This is the boundary known as the event horizon. The event horizon is perhaps the most absolute demarcation line in all of astrophysics. It is the sphere of no return. To understand the horizon, we must consider the concept of escape velocity. When you throw a stone into the air on Earth, it falls back down because it did not possess enough speed to break free of the planet's gravitational pull. For a rocket to leave Earth, it must travel at approximately 11 kilometers per second. If the Earth were denser, the gravity would be stronger, and the necessary escape velocity would be higher. As we approach the black hole, the gravity becomes exponentially stronger, and the required escape velocity rises in tandem. The event horizon is the exact mathematical boundary, dictated by the Schwarzschild radius, where the escape velocity equals the speed of light. Light, traveling at nearly 300,000 kilometers per second, is the absolute speed limit of the universe. Nothing can travel faster. Therefore, if the escape velocity at the event horizon requires a speed greater than light, it means that nothing, absolutely no information, no radiation, and no matter, can escape once it has crossed this threshold. When we look toward a black hole, we do not see a physical object. We see the absence of light. We see a perfect, flawless sphere of absolute darkness, silhouetted against the ambient glow of the universe. The event horizon is not made of matter, it is a geometrical consequence of general relativity. It is a one-way membrane in the fabric of spacetime. You can pass through it from the outside in, but the universe entirely ceases to exist for you from the inside out. The boundary is entirely intangible. If you were an observer drifting freely in the vacuum of space, falling toward a supermassive black hole, you would not feel a physical barrier as you cross the event horizon. There is no surface to strike, no atmosphere to ignite. You would simply glide silently across a mathematical coordinate in space, unaware that your fate had become inextricably bound to the central depths of the object. But, to an outside observer, watching you fall from a safe distance, your journey would appear vastly different. Because immense gravity warps time, just as it warps space. The outside observer would see your descent slow down as you approach the horizon. The light reflecting off you would stretch, becoming redder and dimmer in a process known as gravitational redshift. To the outside universe, you would never appear to actually cross the event horizon. Your image would simply freeze, slowly fading into the infrared, then microwaves, then radio waves, until you disappeared entirely from detection, suspended forever in a state of suspended animation at the edge of the abyss. This separation of perspectives highlights the deeply isolating nature of the black hole. It severs the causal link between the interior and the rest of the cosmos. Whatever lies beyond the event horizon is forever removed from the observable universe. Yet, while the black hole itself is perfectly dark, the environment immediately surrounding it is often one of the most luminous and violent regions in the cosmos. As we conclude our initial descent and prepare to examine the structures that orbit the darkness, we find that the horizon of the unknown is framed by a swirling, blinding tempest of superheated matter. The anatomy of a black hole is not just the silence of the void, but the brilliant, chaotic dance of the material that slowly spirals toward its final, inevitable destination. We will soon navigate this radiant maelstrom, tracing the path of matter as it prepares to slip beneath the veil of the event horizon. As we leave the chaotic luminescence of the accretion disk behind, the temperature drops, not in a physical sense, but in the sudden cessation of observable energy. We are now drifting toward the most profound demarcation line in the architecture of the cosmos, the event horizon. It is a boundary that separates the knowable universe from the absolute unknown. To the uninitiated observer, it appears simply as a sphere of perfect, unyielding blackness, a silhouette cut from the glowing fabric of reality. But this darkness is not an object. It is a symptom. It is the visual manifestation of gravity overwhelming the fundamental constants of nature. To deeply understand the event horizon, we must strip away our earthly intuition of physical surfaces and instead embrace the cold, elegant mathematics of relativity. In the quiet winter of 1915, the physicist Karl Schwarzschild found an exact mathematical solution to Albert Einstein's newly published field equations. He calculated the curvature of space outside in a rotating, spherical mass. Embedded within his elegant proof was a terrifying implication. Schwarzschild discovered that if an object of any mass is compressed into a sufficiently small radius, the escape velocity from its surface would exceed the speed of light. This critical threshold is now known as the Schwarzschild radius. It is not an arbitrary measurement. It is a precise mathematical ratio, defining the exact coordinate where the geometry of spacetime collapses inward upon itself. Consider the clinical mechanics of escape. To leave the surface of any celestial body, an object must be propelled with sufficient kinetic energy to overcome the negative potential energy of the gravitational well. As the mass of the body increases, or as its radius decreases, the well grows deeper, and the required escape velocity climbs. The speed of light, moving at nearly 300,000 kilometers per second, represents the absolute limit of our universe. It is the maximum rate at which information, causality, or energy can propagate through the vacuum. When a dying star shrinks past its Schwarzschild radius, the equations dictate that the required escape velocity surpasses this cosmic speed limit. Because nothing can travel faster than light, the well becomes a flawless, inescapable trap. The event horizon is simply the mathematical sphere surrounding the collapsed mass, where the escape velocity equals the speed of light exactly. To visualize this phenomenon, we must alter our perception of how light travels. Light does not possess mass, but it is inextricably bound by the topography of spacetime. A photon always travels in a straight line, but in the presence of extreme gravity, the space itself is curved. These paths, known as geodesics, are the natural trajectories of light across a warped four-dimensional manifold. Far from the black hole, these geodesics are relatively flat, undisturbed by the distant mass. But as we draw closer, the space-time manifold dips precipitously. The straight lines are forced to bend. Light passing too closely is deflected, its trajectory irrevocably altered by the invisible weight of the collapsed core. Just outside the event horizon, at a distance precisely 1.5 times the Schwarzschild radius, we encounter a region of sublime, mathematical beauty known as the photon sphere. Here, the gravity is so intensely calibrated that the geodesics wrap completely around the black hole in perfect, fragile circles. Photons of light are caught in an eternal, precarious orbit. If you were to hover perfectly still within this sphere, looking straight ahead into the vacuum, the light radiating from the back of your own head would travel entirely around the black hole and into your eyes. You would see your own past, eternally looping in a halo of trapped radiation. But this orbit is unstable. A millimeter of movement inward, and the photon spirals down into the dark. A millimeter outward, and it escapes back into the vastness of the cosmos. Moving past the photon sphere, the curvature becomes agonizingly steep. We approach the boundary, the event horizon itself. It is critical to reiterate that this is not a tangible barrier. There is no surface tension, no collision, no sudden shift in temperature or atmospheric friction. If you were falling into a supermassive black hole, one containing billions of times the mass of our sun, you would cross this threshold without experiencing any localized physical trauma. The horizon is immense, the tidal forces at its edge gentle and deceptive. You would drift across the mathematical coordinate in complete silence. You would not even notice the exact moment you left the observable universe behind. But the moment the threshold is crossed, the physics of reality undergo a terrifying and profound inversion. In our everyday existence, space is a dimension we can traverse in any direction. We can move left, right, forward, and backward at will. Time, however, is a relentless, one-way vector. We are forced to move forward into the future, unable to step back into the past. Inside the event horizon, the mathematics of general relativity dictate that space and time swap their fundamental roles. Once inside the horizon, the radial direction, the path pointing toward the center of the black hole, ceases to be a spatial dimension. It becomes a temporal one. Just as you cannot stop yourself from moving into tomorrow, you can no longer stop yourself from moving toward the center. The singularity is no longer a place in space, it is an inevitable event in your future. No amount of thrust, no advanced propulsion system, no desperate struggle can reverse your course. To fire a rocket engine away from the center would only accelerate your journey toward it, because every possible path, every conceivable direction you could turn now points inward. The geometry of space-time has become a funnel, and all timelines terminate at the deepest point of the well. This inverted geometry is precisely why light cannot escape. It is not that the light is pulled backward by some invisible magnetic chain. It is that, inside the event horizon, there are simply no paths that lead outward. The geodesics themselves curve back toward the center. A photon emitted from a light source pointed directly at the theoretical exit would still travel relentlessly downward. The concept of out has been mathematically erased from the local universe. The profound darkness of a black hole is not the absorption of light. It is the geometric impossibility of its departure. While a supermassive black hole offers a gentle crossing, a stellar mass black hole, one born from the collapse of a single giant star, is infinitely more violent. Because its mass is concentrated in a much smaller radius, the gradient of gravity, the difference in gravitational pull over a short distance, is unimaginably steep. If you were to approach a stellar mass event horizon, the gravitational pull on the lower half of your body would be exponentially stronger than the pull on your upper half. This differential in force, known as a tidal force, would begin to stretch you vertically and compress you horizontally in a relentless physical distortion. In the realm of astrophysics, this process is given the rather whimsical name of spaghettification, but the clinical reality is one of absolute molecular dismantling. As you fall closer to the horizon, the stretching force exceeds the tensile strength of physical matter. You are drawn out into a long, thin filament. But the process does not stop at the macroscopic level. The tidal forces continue to escalate, overcoming the electromagnetic bonds that hold individual molecules together, tearing them apart into their constituent atoms. And eventually, even the atoms themselves are stripped of their electrons, reduced to a stream of subatomic particles raining down into the abyss. This violent deconstruction occurs in fractions of a second, an instantaneous return to primordial matter at the very edge of the void. Yet, for an observer safely distanced from this phenomenon, watching the descent unfold, the mechanics of time dilation present a completely different narrative. As the extreme mass warps the temporal dimension, the closer the falling matter gets to the event horizon, the slower its clock ticks relative to the rest of the universe. The violent tearing apart, the swift plunge into the dark, is never witnessed by the outside world. Instead, the matter appears to decelerate. It smears across the invisible sphere, its light stretching into longer and longer wavelengths, until it fades into undetectable infrared and radio frequencies. The event horizon becomes a graveyard of frozen moments, a shell capturing the final, infinitely slow decades of everything that has ever fallen toward it. This creates a profound and haunting juxtaposition. From the perspective of the falling object, the journey across the horizon into the crushing depths is swift, inevitable, and strictly governed by the relentless forward march of inverted time. But from the perspective of the universe left behind, the object never truly vanishes. Its information, its chemical makeup, its physical history, is theoretically plastered onto the two-dimensional surface of the event horizon, encoded in the stretching quantum fields. This duality, this fundamental disagreement between the experience of the observer and the experience of the fallen entity, lies at the center of our ongoing struggle to unify gravity with quantum mechanics. As we trace the path of these doomed photons and dismantle the geometry of the point of no return, we are left with a profound sense of cosmic isolation. The event horizon is the ultimate censor. It swallows light, matter, and information, permanently sequestering them from the causal flow of the cosmos. It is a boundary of deep silence, a quiet sphere suspended in the interstellar dark. But the journey does not end at the horizon. The horizon is merely the door. Once we have passed through this mathematical membrane, once we have accepted the inevitability of our trajectory, we must look toward the destination that all walked paths now lead to. We must prepare to examine the absolute center, the place where the laws of physics finally shatter. As we leave the mathematical boundary of the event horizon behind, we are no longer distant observers of the abyss. We have become active participants in its profound and inescapable geometry. The threshold has been crossed. We have drifted out of the observable universe and into a sequestered domain where the fundamental laws that govern the cohesion of reality are methodically, relentlessly dismantled. The journey from the horizon to the absolute center is not merely a translation through space, it is a clinical process of physical deconstruction. To understand the fate of matter as it descends into this final darkness, we must deeply analyze the mechanics of the gravitational gradient. In our everyday terrestrial experience, the pull of gravity feels entirely uniform. As you lie resting right now, the gravitational force anchoring your feet to the earth is, for all practical purposes and measurements, identical to the force anchoring your head. We exist in a shallow, gentle depression in the fabric of spacetime, where the local gravity changes so gradually over distance that it appears constant. But a black hole is not a shallow depression. It is an infinitely deep puncture wound in the cosmic tapestry. As matter moves closer to the center of this collapsed mass, the curvature of spacetime plunges with a sudden, exponential steepness. The gravity does not merely increase, the rate at which it increases accelerates drastically. This steepening gradient creates an environment where the gravitational pull across even a microscopic distance becomes devastatingly vast. This differential pull, the difference in acceleration between 2 points of a single object, is what physicists define as a tidal force. We can observe gentle tidal forces in our own solar system. It is the exact same mechanical principle that allows our moon to subtly stretch the Earth, lifting our vast oceans into high and low tides. The side of the Earth facing the moon is pulled slightly harder than the center of the Earth, and the center is pulled slightly harder than the far side. But here, in the deepening well of a stellar mass black hole, this mundane celestial mechanic is magnified to a terrifying, absolute extreme. Consider, if you will, an object of solid matter drifting freely across the event horizon. It could be a wandering rogue planet, a fragment of a shattered comet, or a theoretical vessel of dense metal. As it plunges deeper into the interior of the black hole, the leading edge of the object, the part closest to the center, begins to experience a drastically stronger gravitational pull than its trailing edge. The object is forcefully, unyieldingly pulled faster at its base than at its peak. Simultaneously, because the geometry of spacetime dictates that all possible paths are now converging inward toward a single, infinitely small point, the object is not only stretched along its vertical axis, but, It is simultaneously compressed along its horizontal plane. In the clinical, often stoic language of astrophysics, this dual process of extreme vertical elongation and lateral compression is referred to as spaghettification. It is a deceptively simple, almost whimsical term for what is, in reality, the absolute mechanical failure of solid matter. It is the silent, inevitable undoing of physical structure. Every physical object in the universe is held together by structural integrity. Steel, rock, ice, and bone, they all possess immeasurable tensile strength. This is the absolute limit of stress they can endure before they bend, warp, and finally yield. As our hypothetical object falls deeper into the gravitational well, the tidal forces rise on an exponential curve. There is a precise, mathematically inevitable coordinate in the descent where the differential gravity tearing the object apart exceeds the object's maximum tensile strength. The object does not violently explode or shatter, as such events typically require outward energetic forces or atmospheric friction. Instead, it islandly, fluidly yields. The solid matter is drawn out. It flows. It becomes a long, continuous filament of material, a glowing river of debris stretching endlessly downward. The physical shape of the object, its history, its architecture, is instantly erased, smoothed out into a singular line of descending mass. But the black hole is a meticulous anatomist, and its scalpel is gravity. The deconstruction does not pause at the microscopic scale. As the filament of matter continues its terrifyingly swift descent, the tidal gradient becomes so unbelievably severe that it begins to act over microscopic, internal distances. We must now zoom in, past the visible structure, and descend into the atomic architecture of the falling matter. In the bright, observable universe above, the solid illusion of matter is maintained by the electromagnetic force. This is the fundamental interaction between the positively charged atomic nucleus and the negatively charged electrons. It is the sharing and trading of these tiny electrons between individual atoms that forms chemical bonds, creating the complex molecules of everything we know. Under normal cosmic conditions, electromagnetism is vastly stronger than gravity on the microscopic scale. It is the force that allows a fragile, tiny magnet to hold a piece of iron against the gravitational pull of the entire planet Earth. It is the force that keeps the atoms in your body from collapsing through the floor beneath you. But deep within the event horizon, gravity reclaims its absolute supremacy. It bows to nothing. The stretching forces become so immense, so overwhelmingly powerful, that they begin to outcompute the electromagnetic bonds, holding molecules together. The complex chemistry of the falling object, whether it be the rigid silicate lattice of a crushed moon, or the intricate, delicate carbon structures of organic biology, is cleanly and permanently severed. Molecules are pulled apart into their constituent atoms. The material is reduced to a fundamental dust. It becomes a continuous, elementary stream cascading down the temporal funnel of inverted space. The matter is being systematically purified, stripped of its complex associations. Yet, the gradient continues to steepen. The center draws infinitely closer. The tidal forces now begin to operate across the diameter of a single atom. The infinitesimal distance between the orbiting electron cloud and the dense central nucleus becomes a battleground of fundamental physical laws. The pull of gravity on the leading edge of the atom is now drastically stronger than the pull on its trailing edge. The elegant probabilistic orbits of the electrons, which once formed perfect spherical shells, are violently warped. They are drawn out into elongated, unstable teardrops of probability. The electromagnetic tether strains, fighting a losing battle against the curvature of space. And then, the tether snaps. The electrons are forcefully, permanently stripped away from the nuclei. The matter is no longer a collection of distinct elemental atoms, like iron, carbon, or oxygen. It is now a hyper-compressed, ultra-hot plasma of disconnected subatomic particles. Protons, neutrons, and electrons are violently separated from one another, dragged downward in a chaotic, blindingly rapid descent, unable to ever recombine. As the matter approaches the final, infinitesimally small fractions of a second before it reaches the singularity, even the strongest force in nature is challenged. The strong nuclear force, the incredibly powerful, short-range bond that binds protons and neutrons tightly together within the nucleus itself, begins to feel the strain of the infinite gradient. The tidal forces continue their exponential climb toward infinity, knowing no upper limit. The bare nuclei are stretched, deformed, and eventually torn apart into a raw, unorganized stream of their most fundamental constituents, quarks and gluons. This is the profound, clinical reality of spaghettification. It is not merely the destruction of a physical object, it is the systematic, unyielding erasure of identity. The black hole does not care what it is consuming. It makes no distinction between a lifeless asteroid, a cloud of primordial hydrogen, or a repository of complex technological information. It reduces all things, no matter how intricate, to their most basic mathematical properties: mass, electric charge, and angular momentum. Every defining characteristic of the matter, its entire cosmic history, its shape, its chemical composition, is meticulously stripped away, smoothed out, and lost to the surrounding vacuum. The matter is unanonymized. It becomes pure, fundamental data feeding the mass of the void. From the perspective of the subatomic particles themselves, this entire symphony of extreme deconstruction occurs in a shockingly brief window of proper time. Once the event horizon is crossed, the journey to the center is not measured in years, days, or even hours. It is measured in milliseconds. There is no lingering, there is no struggling. There is only a swift, silent, and absolute dissolution. The matter does not scream as it is torn apart. Sound cannot propagate in the true vacuum of space, and there is no medium to carry the shockwaves of its destruction. There is only the quiet, majestic triumph of curved spacetime acting upon mass. We are left with a stream of fundamental energy, a river of mass entirely stripped of all context, flowing relentlessly toward a destination that defies the very laws of physics that created it. The matter has been perfectly prepared, thoroughly and brutally deconstructed, for its arrival at the absolute deepest point of the gravitational well. It is time to follow this stream to its ultimate, terrifying conclusion. As we sink deeper into the silence, we must now confront the mathematical anomaly at the heart of the darkness. We must prepare to examine the singularity. To deeply understand the anatomy of a black hole, we must first allow ourselves to fundamentally alter our relationship with time. On our quiet, spinning planet, we are conditioned from birth to view time as an absolute construct. We perceive it as an invisible, unyielding river that flows at a constant, uniform pace, carrying all of us forward at exactly the same speed. A passing second is a passing second. Whether you are resting perfectly still at the bottom of the deepest ocean or hurtling through the thin, frigid air of the upper atmosphere. This is the comforting, intuitive illusion of a clockwork universe. But out here, in the profound, silent dark between the stars, where the architecture of reality is pushed to its absolute breaking point, this comforting illusion shatters completely. Time is not a static backdrop. It is not an independent, passive state upon which the grand events of the cosmos simply play out. Time is a deeply physical, malleable dimension, woven seamlessly and inextricably into the three dimensions of space. Together, they create a plant, four-dimensional manifold that physicists refer to as spacetime. And just as a massive celestial object warps the geometry of space, creating the deep gravitational wells that pull matter inward, it equally and inescapably warps the geometry of time. This is the staggering, beautiful revelation at the heart of general relativity. It does not merely dictate how physical objects move through the void, it dictates the very rate at which time is permitted to flow. The underlying principle is elegantly simple, yet its mechanical consequences are terrifyingly profound. The stronger the gravitational field, the slower time passes relative to an observer stationed in a much weaker field. This localized slowing of clocks is known in astrophysics as gravitational time dilation. In the shallow, gentle gravity of our home solar system, this dilation is infinitesimally small, measurable only by the most painstakingly calibrated atomic instruments. But as we approach the absolute, crushing gravity of a collapsed stellar core, the warping of time ceases to be a cephal nuance. It becomes the dominant, overwhelming feature of reality. The gradient of time dilation steepens exponentially, creating a profound temporal disconnect between different regions of the universe that is physically impossible to bridge. To observe this phenomenon in its purest, most clinical form, let us conduct a quiet, hypothetical experiment in the vacuum. Let us imagine releasing a luminous mechanical probe, a brightly glowing sphere equipped with a highly visible, ticking clock on a direct, unpowered trajectory toward the black hole. We will remain safely behind, anchored in the flat, undisturbed space far from the gravitational well, watching through powerful, cold lenses as the probe begins its silent descent into the dark. From the solitary perspective of the probe itself, the journey is entirely unremarkable. The internal mechanics of the descending sphere function perfectly. The clock on its surface ticks away at a steady, rhythmic, comforting pace of exactly 1 second per second. The onboard computers record spatial data normally for the falling object, governed entirely by what physicists term its proper Turing. There is no localized slowing down, no strange or disorienting temporal distortion. It simply falls, accelerating relentlessly and smoothly into the abyss, crossing the mathematical threshold of the event horizon in a matter of fleeting moments. The entire descent, from the outer edges of the accretion disk to the crushing depths of the interior, is experienced as a swift, uninterrupted event. But we are not falling with the probe. We are the distant observers, suspended in a different temporal reality, and our visual experience of this event is fundamentally, inconsolably different. As the glowing probe ventures deeper and deeper into the gravitational well, the light it emits must struggle fiercely to reach our distant lenses. Light, eternally bound by the absolute laws of physics, can never slow its physical speed through a vacuum. It must always travel at nearly 300,000 kilometers per second. As the radiating photons climb upward out of the deepening gravity, they are forced to expend immense amounts of energy. Because they cannot lose speed, they pay this gravitational toll by losing frequency. The very waves of light are stretched out, elongated by the severe curvature of the space they must traverse. This stretching of the illuminating waves is a phenomenon known as gravitational redshift. As we watch the spherical probe fall deeper into the well, its brilliant, stark white light begins to subtly, quietly alter. It shifts gracefully toward the yellow spectrum, then deepens into a bruised, heavy orange, and finally settles into a dark, smoldering red. But the shifting, dimming color is only the visual, superficial symptom of a much deeper, more profound distortion occurring beneath the surface. The physical stretching of the light waves is inextricably, mathematically linked to the stretching of time itself. because the ambient gravity is unimaginably stronger at the current position of the probe than it is at our distant, safe observation point. The flow of time for the probe is fundamentally slower relative to the ticking of our own local clocks. As the probe draws ever closer to the event horizon, we do not see it rapidly accelerate into the abyss as Newtonian physics would suggest. Instead, we see it begin to steadily, inevitably decelerate. The rhythm of its descent becomes increasingly sluggish, deeply lethargic, as if it is sinking not through a vacuum, but through an incredibly dense, invisible resin. Through our telescopes, we focus intensely on the mechanical clock mounted to the surface of the probe. When the journey began, it ticked in perfect, synchronized harmony with our own instruments. But now, we see the dark space between the ticks growing wider and wider. What takes one solitary second to cast on our clock suddenly takes 2 seconds on the descending probe, then a minute, then a long quiet hour. The temporal disconnect is widening exponentially, the two realities permanently severing from one another in real time right before our eyes. As the falling probe approaches the exact mathematical boundary of the event horizon, the threshold defined by the short-swelled radius, the gravitational time dilation, approaches absolute infinity. The required escape velocity from that coordinate is climbing perfectly toward the speed of light, and the curvature of the spacetime manifold is becoming infinitely steep. At the very edge of the ultimate darkness, the visual reality of the observable cosmos breaks down completely from our distant, anchored perspective. The glowing probe never actually crosses the event horizon. It simply cannot. As it gently touches the absolute threshold, a flow of time on the surface of the probe, relative to our distant position, grinds to an absolute, permanent, and silent halt. The image of the falling sphere freezes perfectly in place, becoming a static, motionless ghost suspended against the perfect, unyielding blackness. We watch in deep silence, as the second hand on the probe's clocks, moving entirely, the ticking forever ceases. The physical object is caught in a state of eternal, unmoving suspended animation, locked visually in the exact, infinitesimal fraction of a millisecond before it theoretically crossed the threshold. Two distant observers waiting in the flat space, it takes an infinite amount of time for the probe to fall through the horizon. The universe will literally end. The remaining stars will quietly burn out and fade to cold ash, long before we ever see the probe physically breach the barrier. But the frozen, static image does not remain clearly visible to our eyes. The merciless gravitational retrofit continues its relentless, silent work. The light stretching outward from the frozen probe becomes increasingly longer. The fragile electromagnetic waves drawn out further and further by the crushing, unending gravity. The deep, smoldering red fades entirely and permanently from the visible spectrum. The image of the probe shifts downward into the infrared, becoming entirely invisible to the naked human eye. As the years, decades, and centuries pass in our uninterrupted reality, the light stretches further still, lengthening into microwaves, and eventually dissolving into faint, ultra-low radio wave. The probe is still theoretically there, its frozen, motionless image plastered eternally onto the mathematical, two-dimensional surface of the event horizon, but its signal becomes endlessly fainter, endlessly stretched, until it is completely indistinguishable from the faint, static background radiation of the cosmos. It fades into an undetectable, ghostly whisper, a phantom echo of an object that, from its own localized perspective, fell smoothly to its destruction long ago. This creates one of the most haunting, deeply beautiful, and isolating paradoxes in all of modern astrophysics. A black hole is not merely a dark graveyard of crushed matter, it is a meticulously preserved graveyard of frozen time. The silent surface of the event horizon, from the perspective of the outside universe, is coated in the layered, perfectly preserved, two-dimensional echoes of everything that has ever fallen toward it throughout the billions of years of cosmic history. Every shattered fragment of a wandering comet, every solitary photon of ambient starlight that has ever approached the final boundary and still there, frozen in an eternal stillness, slowly fading into the deepest, unmeasurable frequencies of the electromagnetic spectrum. The black hole acts as an ultimate cosmic archive, a silent, spherical canvas holding the final, static moments of countless cosmic entities, all suspended infinitely at the exact moment of their departure from the observable universe. This temporal isolation is absolute. Once the frozen image forms on the horizon, no further information can ever be transmitted back to the waking world. If the descending probe were to somehow emit a signal back to us after it crossed the threshold, the signal would physically have to travel backward through time to reach our distant lenses, a fundamental violation of causality that the architecture of the universe strictly, unconditionally forbids. The severing is total. We are left staring at a fading ghost, a lingering optical illusion maintained solely by the extreme curvature of spacetime. While the physical reality of the probe has already met its unseen fate in the crushing depths below, we must dwell quietly on this profound silence for a moment. As you rest, and allow the heavy weight of these celestial mechanics to settle deeply into your mind, consider the sheer, clinical elegance of this temporal severing. The universe does not mourn the loss of matter to the void. It simply stretches the departing light, slows the final, fleeting moment to an eternal standstill, and quietly files the fading echo into the dark. There is no violence in the frozen image. There is only stillness, undisturbed mathematical calm at the edge of absolute annihilation. But while the outside universe is left with only a fading, static projection, the physical reality inside the horizon continues its violent, unseen, and inevitable progression. The extreme time dilation that created the peaceful ghost on the surface is entirely irrelevant to the matter currently plunging ever deeper toward the center. Having meticulously deconstructed the temporal illusion at the boundary, we must now prepare to leave the comforting perspective of the distant observer behind permanently. We must gently shift our focus back to the falling matter, back to the brutal, inward-pointing geometry of the interior, as it races relentlessly toward a destination where neither space nor time can retain any meaning at all. To deeply understand the anatomy of a black hole, we must first allow ourselves to fundamentally alter our relationship with time. On our quiet, spinning planet, we are conditioned from birth to view time as an absolute construct. We perceive it as an invisible, unyielding river that flows at a constant, uniform pace, carrying all of us forward at exactly the same speed. A passing second is a passing second. Whether you are resting perfectly still at the bottom of the deepest ocean or hurtling through the thin, frigid air of the upper atmosphere. This is the comforting, intuitive illusion of a clockwork universe. But out here, in the profound, silent dark between the stars, where the architecture of reality is pushed to its absolute breaking point, this comforting illusion shatters completely. Time is not a static backdrop. It is not an independent, passive state upon which the grand events of the cosmos simply play out. Time is a deeply physical, malleable dimension, woven seamlessly and inextricably into the three dimensions of space. Together, they create a blind, four-dimensional manifold that physicists refer to as spacetime. And just as a massive celestial object warps the geometry of space, creating the deep gravitational wells that pull matter inward, it equally and inescapably warps the geometry of time. This is the staggering, beautiful revelation at the heart of general relativity, does not merely dictate how physical objects move through the void. It dictates the very rate at which time is permitted to flow. The underlying principle is elegantly simple, yet its mechanical consequences are terrifyingly profound. The stronger the gravitational field, the slower time passes relative to an observer stationed in a much weaker field. This localized slowing of clocks is known in astrophysics as gravitational time dilation. In the shallow, gentle gravity of our home solar system, this dilation is infinitesimally small, measurable only by the most painstakingly calibrated atomic instruments. But as we approach the absolute, crushing gravity of a collapsed stellar core, the warping of time ceases to be a subtle nuance. It becomes the dominant, overwhelming feature of reality. The gradient of time dilation steepens exponentially, creating a profound temporal disconnect between different regions of the universe that is physically impossible to break. To observe this phenomenon in its purest, most clinical form, let us conduct a quiet, hypothetical experiment in the vacuum. Let us imagine releasing the luminous, having left the frozen, optical illusions of the event horizon far behind. We now commit ourselves entirely to the crushing interior dark. The matter that was once a glowing probe, or a shattered comet or a dying star, has been violently reduced to a hyper-accelerated stream of fundamental, disconnected particles. It is plunging down a gravitational well that possesses no physical bottom, guided relentlessly by the inward-pointing geometry of inverted time. It is here, in the suffocating, absolute islands of the core, that we must confront the ultimate destination. We have arrived at the absolute center of the black hole. In the cold, exacting language of astrophysics, this coordinate is called the gravitational singularity. To truly comprehend the nature of this concept, we must once again carefully dismantle our earthly, comforting intuitions about the physical nature of reality. When we conceptualize a physical object, even a microscopic one resting on a slide, we inherently assign it dimensions. We understand it to possess height, width, and depth. It occupies a measurable, finite volume of space. Even the fundamental, subatomic particles, the quarks and electrons screaming downward into the abyss, exist within the spatial parameters of the quantum world. But as this river of dismantled matter reaches the exact mathematical center of the black hole's immense mass, the very concept of spatial dimension is violently, permanently eradicated. The singularity is not a highly compacted sphere of matter. It is not a dense, dark star hidden deep within the void. It is, according to the strict, uncompromising mathematics of Albert Einstein's general relativity, a dimensionless point. It is a singular, localized coordinate where the entire, unfathomable mass of the original collapsed star is potentially equivalent to billions of our suns is compressed into a volume of absolute, perfect zero. Let those words settle gently and heavily into your mind for a moment. Zero volume, infinite density, aptly rational realm of mathematics, dividing any finite, physical number by zero yields infinity. It is a mathematical anomaly, an undefined, chaotic error in the otherwise elegant equations of the cosmos. When theoretical physicists encounter infinity in their calculations, they do not view it as a profound, physical truth. They view it as a flashing, unavoidable warning sign. It is a stark signal that the mathematical framework they are using to describe the universe has fundamentally broken down. General relativity is the most elegant, precise, and rigorously tested theory of gravity humanity has ever conceived. It perfectly predicts the slow, elliptical orbits of the planets, the subtle bending of ancient starlight around massive galaxies, and the precise, inescapable mechanics of the event horizon we just traversed. It is the absolute master of the macroscopic universe, the architect of the massive. General relativity is a theory of smooth, continuous curves. It views spacetime as a flawless, uninterrupted sheet, bending and warping gracefully under the weight of stars and planets. But at the singularity, the curvature of this spacetime manifold does not merely bend, it becomes infinitely steep. The localized gravity becomes infinitely strong. The smooth, continuous sheet of reality is stretched beyond its breaking point, and the master equations of relativity finally, violently shatter. General relativity cannot describe what happens at a singularity because the concept of spacetime itself, the very stage upon which gravity acts, ceases to exist at that precise coordinate. To attempt to understand the point of zero volume, we must transition from the science of the immense to the science of the incredibly small. We must turn our gaze from the stars and look toward quantum mechanics. Quantum mechanics is the master of the microscopic, the strange and probabilistic rulebook for atoms, electrons, and the fundamental forces of nature. It dictates that energy and matter come in distinct, discrete, indivisible packets called quanta. It is a theory of the grainy, the jumping, and the uncertain. But herein lies the greatest, most agonizing paradox in all of modern theoretical physics. General relativity and quantum mechanics, the two foundational, flawlessly proven pillars of our understanding of reality, completely refuse to work together. They are mathematically incompatible, speaking entirely different languages. In the vast, open cosmos, they can peacefully coexist by ruling their separate, distinct domains. Gravity handles the sweeping, silent motions of the galaxies, while quantum mechanics handles the erratic, invisible dancing of the atoms. But at the heart of a black hole, a new unimaginably huge amount of mass is crushed into an infinitesimally microscopic space. Both theories demand absolute jurisdiction over this single dimension source point. When physicists bravely attempt to combine the equations of gravity with the equations of quantum mechanics to describe the exact conditions of the singularity, the mathematics explode into nonsensical, chaotic infinities. The resulting equations predict probabilities greater than 100%, a logical, physical impossibility. They declare a state of absolute mathematical war, yielding answers that offer no insight into the darkness. This piece that right now, at this exact moment in the quiet history of human civilization, we simply do not possess the scientific language to describe the true physical nature of a black hole's core. The singularity is a gaping, silent hole in our understanding of the cosmos. It is a profound mystery wrapped in a mathematical error. To pierce this final veil, to translate the chaotic infinities back into rational, measurable numbers, humanity must discover a unified theory of quantum gravity. We must find a way to quantify the fabric of spacetime itself. We must prove whether space and time are not smooth, continuous sheets, but are instead composed of tiny, discrete, indivisible pixels, a quantum foam that prevents matter from ever truly reaching a volume of zero. Until that unified theory is found, the singularity remains a dark, locked door at the end of the universe. Yet nature itself seems deeply, inherently invested in protecting the wider cosmos from this breakdown of physical law. In 1916, the theoretical physicist Roger Penrose proposed a concept known as the cosmic censorship hypothesis. Penrose observed a profound and comforting pattern in the architecture of the void. The universe, it seems, absolutely abhors a naked singularity. The hypothesis suggests a deeply reassuring defense mechanism built into the fabric of reality. That whenever a singularity forms from the violent, gravitational collapse of a massive star, the universe instantaneously, almost defensively, drapes an event horizon around it. The breakdown of physical law is permanently, safely quarantined behind a one-way membrane of trapped light. The universe is an orderly, rational system, strictly governed by the ironclad laws of cause and effect. If an event occurs, it must have a cause that preceded it in time. But at the singularity, where time is eradicated, causality itself is threatened. If the singularity were ever exposed, if there were no event horizon to hide it in the dark, the infinite density could theoretically radiate unpredictable, impossible, and unsourced information out into the surrounding galaxy. The basic, comforting laws of physics would be subject to random, chaotic events that defy all logic. To protect the sanity and order of the cosmos, the universe employs the event horizon as a perfect, impenetrable quarantine zone. It is the ultimate cosmic censor. No observer in the external universe can ever look upon the infinite density of the singularity and witness the failure of reality. Broken infinities are locked away in the eternal dark, prevented from infecting the predictable, orderly progression of the stars outside. But what of the doomed matter itself? What is the absolute final fate of the spaghetti-feed plasma that reaches this dimensionless point? If it cannot occupy space, where does the physical mass go? In the absence of a unified theory, we are left only with the quiet whispers of theoretical mathematics. Some models suggest that the matter is simply crushed entirely out of physical existence, its mass converted purely into the extreme mathematical curvature of spacetime itself. The star becomes nothing more than a geometric memory, an indentation in the void. Other physicists propose that quantum effects at the very last, infinitesimally small fraction of a millimeter prevent the formation of a true zero-volume point. In this scenario, the collapse is halted by an unknown, immensely powerful quantum repulsion, creating an ultra-dense, microscopic, but physically real core known as a Planck star. And there are older, more mesmerizing, and deeply unsettling theories. Hidden deep within the complex mathematical loopholes of relativity is the suggestion that a spinning singularity might not be a single point, but a dimensionless, rapidly rotating ring. In falling through the exact center of this ring might not lead to ultimate physical destruction, but to a profound, incomprehensible displacement. The mathematics hints at a theoretical exit strategy, a sudden, violent transition into another region of space, another era of time, or perhaps another universe entirely. This is the theoretical concept of a white hole, the exact time reversed opposite of a black hole, blasting the consumed, recycled matter back out into a newly born cosmos, sparking the creation of fresh, unseen stars. But these are only the faint echoes of equations, theories drifting in the profound silence of the unknown. We cannot observe them, we cannot test them. The undeniable truth of our current reality is that the singularity remains the absolute end of the observable journey, is a quiet, dark monument to the absolute limits of human knowledge. It is a coordinate where time stops its relentless march, where space is perfectly erased, and where all the familiar laws of reality are rewritten in a cosmic language we have yet to learn. As we leave the absolute's enter suspended in its eternal, infinite density, we begin our slow ascent back toward the surface. The anatomy of a black hole is not defined solely by its crushing center or its dark boundary. As we transition back to the wider cosmos, we must prepare to observe the slow, methodical, and almost imperceptible process by which these eternal monuments eventually, inevitably die. As we begin our gentle ascent from the crushing, infinite density of the singularity, traversing back through the temporal funnel and finally slipping past the dark veil of the event horizon, we return to the quiet, observable universe. We look back upon the perfect, lightless sphere suspended in the interstellar void. From this distant, anchored vantage point, a black hole appears as an eternal monument of gravity. It seems to be a permanent, unyielding fixture in the architecture of the cosmos, an immortal devourer of matter and light that will endure forever. But in the grand, sweeping narrative of the universe, the concept of eternity is merely an illusion born of our own fleeting, microscopic lifespans. Nothing in the physical universe is truly eternal. Not the burning stars, not the drifting galaxies, and not even the deepest, darkest gravitational wells. To understand the ultimate fate of a black hole, we must fundamentally shift our perception of time. We must abandon the frantic, rushing clocks of human existence and embrace the slow, unfathomable temescals of cosmic evolution. And we must turn our attention away from the immense, crushing scale of general relativity and look once more to the ghostly, microscopic realm of quantum mechanics. In our everyday intuition, we perceive the vacuum of space as a state of absolute nothingness, an empty, silent void completely devoid of matter or energy. But the framework of quantum field theory reveals a profoundly different reality. The vacuum is not empty. It is a restless, invisible ocean at the subatomic level, governed by the inherent uncertainties of quantum mechanics. Empty space is constantly boiling with microscopic activity. This phenomenon is known as quantum fluctuation. In this unseen, bubbling foam of reality, pairs of virtual particles are continuously popping into existence. They appear as twins, a particle of matter and its corresponding particle of antimatter, possessing negative energy. Because they are created from nothing, they owe a mathematical debt to the universe. To repay this debt and conserve the total energy of the cosmos, these twin particles exist for only an infinitesimally small fraction of a second before they collide, annihilate one another, and vanish back into the void. This silent, microscopic dance of creation and destruction happens continuously, everywhere, in every cubic centimeter of empty space in the universe. Under normal circumstances, in the flat space between the stars, this quantum boiling goes entirely unnoticed. But a profound, reality-altering interaction occurs when this microscopic dance takes place on the exact mathematical knife edge of a black hole's event horizon. Imagine a pair of these virtual particles spontaneously appearing just millimeters from the threshold of no return. They pop into existence deeply entangled, preparing to immediately collide and annihilate. But the gravitational gradient at the horizon is unimaginably steep. In the fleeting fraction of a millisecond before the twins can reunite, the immense tidal forces of the black hole physically tear them apart. One particle, the one closest to the boundary, is dragged violently across the event horizon and swallowed by the dark. The other particle, just outside the threshold, is suddenly freed. Without its partner to annihilate with, it is violently promoted from a virtual, temporary anomaly into a real, permanent particle of physical radiation. It escapes the black hole and flies out into the vastness of space. Microscopic severing of quantum bonds was mathematically proven by the theoretical physicist Stephen Hawking in 1974. It was a revelation that shook the foundations of astrophysics. It proved that black holes are not entirely black. They are not perfect, inescapable traps. They emit a faint, steady stream of thermal energy, an invisible glow that is now known as Hawking radiation. But the universe is an incredibly strict accountant. The fundamental laws of thermodynamics dictate that energy cannot be created from nothing. The particle that escaped into the cosmos now possesses real, positive energy. So, where did this energy come from? The mathematics demand that the debt must be paid by the black hole itself. The particle that fell across the event horizon carried negative energy, and as it crunched into the core, it subtracted an equivalent, minuscule fraction of mass from the singularity. Through this agonizingly slow, microscopic process of quantum leakage, the black hole is literally evaporating. It is losing mass, shedding its immense weight one subatomic particle at a time, bleeding its energy back out into the cold vacuum of the cosmos. This process of evaporation, however, is unimaginably slow. The rate at which a black hole leaks Hawking radiation is inversely proportional to its mass. The larger and heavier a black hole is, the colder it is, and the slower it evaporates. A supermassive black hole, containing the mass of billions of suns, possesses a temperature so close to absolute zero that its evaporation rate is effectively stalled. In the current era of our universe, the ambient background heat left over from the Big Bang is actually warmer than these supermassive giants. Right now, black holes are still actively feeding. They are absorbing more ambient cosmic radiation than they are leaking out. They are growing, not shrinking. To witness the true evaporation of a black hole, we must allow our minds to drift infinitely far into the deep future. We must mentally fast forward through the grand epics of cosmic time. We must watch as the current era of the universe, the Stellar-Fuse era, slowly comes to an end. Over the next 100 trillion years, the vast reserves of hydrogen gas that fuel the birth of stars will be completely exhausted. Glowing tapestries of the galaxies will slowly dim. As star after star exhausts its fuel and quietly dies. Once ablaze with billions of localized suns, will fade to an unbroken velvet black. The universe will enter the degenerate era, a cold, quiet epoch populated only by the cooling embers of dead stars, white dwarfs, neutron stars, and the rogue, wandering planets drifting in the dark. As more trillions of years pass, even these dense, stubborn remnants will decay. The matter will slowly disintegrate, or their decaying orbits will eventually drag them into the waiting maws of the surviving black holes. Roughly 10 to the power of 40 years from now, a number so incomprehensibly vast that human mathematics struggles to contextualize it, the universe will enter the black hole era. The cosmos will be entirely empty of light, empty of life, and empty of conventional matter. The only structures remaining in the infinite, expanding darkness will be the supermassive black holes. They will sit alone, colossal and silent, ruling over a dead, freezing void. It is only now, in this absolute, ultimate isolation, that the ambient temperature of the expanding universe will finally drop below the microscopic temperature of the black holes themselves. It is only now that the process of Hawking radiation will truly, unimpeded, begin to take its toll. In the profound silence of the black hole era, these ancient monuments will begin to slowly leak their mass away. The evaporation of a supermassive black hole is perhaps the most patient, deliberate physical process in all of nature. To evaporate a black hole the size of the one at the center of our Milky Way galaxy will take approximately 10 to the power of 100 years. A 1, followed by 100 zeros. A googol of years. It is a span of time that reduces the entire, multi-billion-year lifespan of our current universe to a fraction of a fleeting blink. For countless eons, the evaporation proceeds at a glacial, almost unmeasurable pace. The black hole sheds mere photons, whispering its mass back into the void. But as the immense weight slowly diminishes, a critical shift occurs. Because smaller black holes are hotter and evaporate faster, the process of Hawking radiation accelerates as the black hole shrinks. It is a compounding loop of physical decay. As the black hole eventually reduces to the mass of a small asteroid, its temperature begins to soar. The slow, quiet whisper of escaping photons becomes a steady, localized stream of X-rays and gamma rays. The black hole is no longer a dark sphere. It is a microscopic, fiercely glowing point of intense, burning energy. The millennia collapse into centuries, the centuries into days, and the days into fractions of a second. The pace of evaporation becomes frenetic, violent. In its final, fleeting moment of existence, the black hole reaches a temperature of trillions of degrees. The last remaining fraction of its mass, perhaps equivalent to the weight of a small mountain, is instantaneously converted into pure raw energy. The black hole dies in a brilliant, blinding flash of hard gamma radiation. It is a silent, spectacular explosion, a final burst of light illuminating the absolute darkness of the deep future. And there is nothing. The mathematical knot in the fabric of space-time entirely unravels. The event her eyes on vanishes. The singularity is resolved. The cosmic scar is finally healed. When the very last supermassive black hole in the cosmos eventually evaporates and detonates in the unimaginable depths of the future, the universe will enter its final, permanent stage of existence, the Dark Era. The cosmos will be an infinitely vast, infinitely expanding ocean of near absolute zero. There will be no stars, no planets, no matter, and no black holes. The universe will be populated only by a faint, cooling mist of photons, neutrinos, and stray electrons, all drifting aimlessly, separated by distances so vast they will never again interact. There is a profound, comforting beauty to this ultimate fate. The universe will not end in a violent, chaotic collapse. It will not tear itself apart. Instead, it will simply wind down. The grand, complex machinery of gravity, thermodynamics, and quantum mechanics will finally exhaust itself. The universe will reach a state of absolute, perfect thermodynamic equilibrium. It is the ultimate state of rest, a cosmic sleep from which the universe will never wake. As you lie in the quiet of your own room, preparing to drift off into your own restful stillness, let the weight of this deep, future peace wash over you. The struggles, the complexities, the bright, burning anxieties of the waking world are all fleeting. Even the most terrifying, powerful, and mysterious objects in reality are destined to quietly dissolve, returning their energy to the void and leaving behind nothing but a cool, silent, and endless peace. Let us gently draw our minds back from the freezing, infinite depths of the deep future. Let us return from the quiet, thermodynamic death of the cosmos and re-anchor ourselves in the vibrant, burning present of the stellar life whose era. We have spent our time thus far examining the stellar mass black holes, those solitary, silent monuments born from the collapse of individual, dying stars. They are the scattered, invisible ghosts wandering the galactic arms. But in the grand, sweeping architecture of the universe, these stellar remnants are merely microscopic anomalies. They are the footnotes in a much larger, unimaginably more violent cosmic narrative. To truly understand the role of these gravitational anomalies, we must vastly expand our sense of scale. We must turn our gaze away from the isolated stellar graveyards and look toward the blazing, chaotic centers of the galaxies themselves. We must prepare to confront the true leviathanness of the dark, the supermassive black holes. The scale of these entities defies all earthly intuition. While a stellar mass black hole might contain the crushed remains of 3 or perhaps 30 of our suns, a supermassive black hole is measured in the millions, and often billions of solar masses. They are the heavy, unseen anchors around which the grand, spiraling tapestries of entire galaxies rotate. They are not merely objects existing within the universe. They are the fundamental, gravitational engines that shape the universe itself. To observe one of these giants, we do not need to look across the unfathomable distances of the intergalactic void. We need only look toward the heart of our own home. Imagine on a journey toward the exact geometric center of the Milky Way galaxy. We must travel 26,000 light-years inward, moving through the spiraling arms of the Orion Spur, navigating past the sprawling, glowing nebulae and the densely packed stellar nurseries. As we draw closer to the galactic core, the environment becomes increasingly hostile and luminous. The interstellar dust thickens into vast, opaque clouds, obscuring the visible light. The density of stars rises exponentially. If the Earth were situated in this central bulge, our night sky would not be a tapestry of distant, twinkling points. It would be an unbroken, blinding canopy of starlight, bright enough to read by at midnight, casting stark, multiple shadows across the ground. Yet, hidden deep within this blinding, chaotic swarm of ancient stars, there is a region of profound, absolute silence. It is a coordinate known to astronomers as Sagittarius A star. For decades, the true nature of this coordinate remained obscured behind the dense curtains of cosmic dust. We could observe its terrifying, majestic influence on the space surrounding it. Using advanced infrared telescopes, astronomers spent years patiently tracking the movements of a specific cluster of massive, brilliant blue stars, the stars that orbit the galactic center. The choreography of these stars is deeply hypnotic and violently beautiful. They do not drift slowly in wide, gentle circles like the planets in our solar system. They whip through space at staggered breakneck velocities, some traveling at nearly 3% the speed of light. They trace long, highly elliptical orbits, behaving exactly like comets plunging toward a sun. But as they reach the absolute lowest point in their orbit, the point of closest approach, they do not swing around a blindingly bright central star. They swing violently around absolutely nothing. They trace an exact, mathematical ellipse around an invisible, dark point in the void, completely undisturbed by any physical surface. By measuring the extreme velocities and the precise orbital trajectories of these stars, the laws of orbital mechanics allow us to calculate exactly how much mass must be hidden in that dark, central point to keep the stars tethered to such tight, violent loops. The mathematics reveal a crushing, inescapable truth. Suspended in that silent, invisible coordinate is a mass equivalent to 4 million of our suns. This unfathomable weight is compacted into a spherical boundary with a radius smaller than the distance between our sun and the planet Mercury. There is only one physical structure in the known universe capable of being so incredibly massive, so perfectly compact, and so entirely devoid of light. Sagittarius A star is the supermassive black hole anchoring the Milky Way. It is the quiet, brooding monarch of our local galaxy, but our local Leviathan is currently sleeping. It is in a state of deep, cosmic starvation, known as quiescence. The immediate vicinity around its event horizon has been swept relatively clear of gas and dust. It occasionally captures a wandering asteroid or strips a thin wisp of plasma from a passing star, releasing a faint, localized flare of X-rays, but for the most part, it sits in the dark, a silent, invisible king. This peaceful slumber, however, is not the default state for these supermassive giants. When a supermassive black hole is actively feeding, when a vast reservoir of cold interstellar gas or a shattered star system falls into its immediate gravitational grip, it undergoes a terrifying metamorphosis. The invisible anchor transforms into the single most luminous, destructive, and energetic phenomenon in the cosmos. It becomes an active galactic nucleus or a quasar. To visualize a quasar, we must strip away the darkness. When billions of tons of matter, begin to spiral downward toward a supermassive event horizon. They do not fall cleanly or quietly. The geometry of spacetime forces the material into a vast, flattened, swirling structure, the accretion disk. On the scale of a supermassive black hole, this disk is incomprehensibly huge, often spanning light years across. As the matter in the disk spirals closer to the event horizon, the gravitational gradient forces the inner layers to orbit drastically faster than the outer layers. This sheer differential in velocity creates an unimaginable, relentless friction. The gas is violently crushed, compressed, and heated to temperatures exceeding hundreds of millions of degrees. The atoms are stripped of their electrons, creating a turbulent, highly magnetized ocean of ultra-hot plasma. The friction becomes so intense that the matter begins to convert its gravitational potential energy directly into brilliant, searing light. The accretion disk of a feeding supermassive black hole burns with a ferocity that defies all earthly comparison. It radiates across the entire electromagnetic spectrum, pouring out radio waves, visible light, ultraviolet radiation, and lethal, hard X-rays. A single quasar, powered by a central black hole no larger than our solar system, can outshine the combined, cumulative light of every single star in its host galaxy. It is a beacon of agonizing brightness that can be seen across billions of light years of expanding space. A lighthouse illuminating the very edge of the observable universe. It is a profound, beautiful cosmic irony. The absolute darkest objects in reality are the engines responsible for creating the most blinding, radiant light ever to exist. But the quasar is not merely a beacon of light, it is an engine of targeted, kinetic violence. The extreme, twisting rotation of the supermassive black hole, combined with the chaotic, churning plasma of the accretion disk, generates magnetic fields of staggering, incomprehensible strength. These magnetic fields become twisted and tightly coiled, forming towering, invisible funnels that burst vertically out from the northern and southern poles of the black hole. A significant fraction of the infalling matter, trapped in the accretion disk and destined for the singularity, is suddenly caught in these magnetic tornadoes. Instead of crossing the event horizon, this matter is violently accelerated outward. It is launched away from the black hole at velocities approaching 99% the speed of light. These are the relativistic jets. They are tightly focused, blindingly bright beams of hyper-accelerated plasma and pure energy, slicing through the cosmic dark like surgical lasers. These jets do not dissipate quickly. They possess so much raw kinetic energy that they punch entirely through the host galaxy, bursting out of the galactic disk and traveling for millions of light years into the empty, intergalactic void. As the jets finally slow down, colliding with the sparse, ambient gas of the deep universe, they bloom into colossal, glowing lobes of radio emission, structures so vast they dwarf the galaxy that birthed them. Astronomers viewed these supermassive black holes simply as destructive, chaotic forces, bottomless pits that devoured matter and blasted sterile, lethal radiation into the cosmos. But as our understanding of galactic architecture has deepened, a profound paradigm shift has occurred. We now realize that a supermassive black hole is not an infection within a galaxy. It is the beating, regulating heart of the system. There is a delicate, intricate symbiosis between the galaxy and the black hole it harbors. The central bulge of stars are always mathematically, directly correlated to the mass of the black hole hidden within it. They grow together, locked in a complex, cosmic feedback loop. When a quasar flares into existence, the sheer, crushing pressure of its intense radiation, combined with the kinetic shockwaves of its relativistic jets, sweeps outward through the host galaxy. This outward pressure pushes against the spalling clouds of cold, primordial hydrogen gas, the very material required to form new stars. The black hole literally heats up the galaxy, blowing the cold gas outward and permanently shutting down the creation of new suns. In this way, the supermassive black hole acts as a grand cosmic thermostat. It regulates the growth of the galaxy, ensuring it does not consume all of its star-forming material too quickly. It prevents the galaxy from burning out in a sudden, chaotic frenzy of stellar birth. It is a destroyer of matter, yes, but it is also the grand architect of order. As we drift here, suspended in the glow of the Milky Way, we must marvel at this perfect, silent balance. The black hole is the anchor, the engine, and the regulator. Beautiful architecture of the cosmos is entirely dependent on the dark, crushing geometry at its core. But even these isolated, regulating leviathans do not always remain solitary in the dark. As the galaxies themselves drift through the expanding web of the universe, they are sometimes drawn into a fatal, inescapable choreography of their own. We must now prepare to witness the most violent and monumental events in the fabric of space-time. We must look to what happens when the leviathans collide. As we expand our vision beyond the solitary, spinning disks of individual galaxies, we must confront the broader, sweeping architecture of the cosmos. The universe is not a static museum of isolated islands. It is a dynamic, unfathomably vast ocean, woven together by invisible threads of dark matter. Along these massive, unseen filaments, galaxies drift. They are pulled by the relentless, patient gravity of their neighbors, caught in a grand, cosmic choreography that plays out over billions of years. Because the universe is governed by the inevitable attraction of mass, these drifting islands are often destined to meet. To understand the ultimate fate of the supermassive black holes we have just observed, we must witness the majestic, terrifying process of a galactic collision. We do not need to look entirely to the distant reaches of the cosmos to find such an event. We are currently participating in one. Our own Milky Way galaxy and our nearest massive neighbor, the Andromeda Galaxy, are locked in a mutual gravitational embrace. They are rushing toward each other across the intergalactic void at a speed of over 100 kilometers per second. In roughly 4 billion years, these two sprawling tapestries of stars will finally touch. But a collision between two galaxies is not a sudden, violent crash of solid matter. It is a deeply deceiving event, a collision of ghosts, because the distances between individual stars are so unimaginably vast. The galaxies are composed almost entirely of empty space. When the Milky Way and Andromeda eventually intersect, the stars will not smash into one another. Our sun will not violently collide with an alien sun. Instead, the two galaxies will seamlessly pass right through each other, like two ethereal clouds of mist intermingling in the night sky. However, physical stars avoid collision. Their gravitational fields do not. The delicate spiral structures of both galaxies will be fundamentally and permanently destroyed. The intense, conflicting gravitational tides will warp and stretch the disks, drawing out immensely long, glowing tails of stars and gas that trail behind them for millions of light years. The galaxies will swing past one another, slowed down by the heavy drag of their mutual gravity, and then they will fall back together, merging unsettling into a new, massive, featureless cloud of stars known as an elliptical galaxy. Sweeping chaos. The billions of stars are relatively safe, merely reassigned to new, chaotic orbits. But the true drama of this collision occurs deep within the obscuring dust of the central core. We must focus our attention back on the leviathans. when the two galaxies merge, their respective supermassive black holes do not casually drift past one another. They are the heaviest anchors in the system, and they are subject to a relentless physical process known as dynamical friction. As these twin black holes move through the newly merged, dense sea of stars and cold interstellar gas, their immense gravity pulls the surrounding matter into a turbulent wake behind them. This wake acts as a cosmic parachute. The gravitational drag slowly, methodically robs the black holes of their forward momentum. Because they are losing energy, they can no longer maintain their wide orbits. They begin to sink. With an agonizing, silent patience, both supermassive black holes slowly spiral downward toward the exact gravitational center of the new, merged galaxy. Deep in the absolute darkness of the core, the two Leviathaness find one another. They become trapped in each other's immediate gravitational well, forming a supermassive binary system. Picture, in your mind's eye, two perfect spheres of absolute blackness, each containing the mass of millions or billions of suns, locked in a tight, heavy waltz. They orbit a shared center of empty space, sweeping through the dark with a terrible, silent majesty. At this stage, their orbit is still relatively wide, perhaps separated by a distance of several light years. But their combined gravity acts as an immense, chaotic paddle, violently churning the core of the galaxy. Any unfortunate star that wanders too close to this binary pair is caught in the complex, shifting gravitational tides. The stars are violently grabbed, whipped around the black holes in a complex slingshot maneuver, and hurled completely out of the galactic core at millions of miles per hour. Through this process, the twin black holes systematically sweep the center of the galaxy entirely clean. They create a vast, hollow sphere in the heart of the new galaxy, a dead zone devoid of stars, gas, and dust. They are left entirely alone in the void they have created. But this isolation presents a profound mechanical problem in astrophysics. To continue spiraling inward and eventually merge, the black holes must continue to lose orbital energy. However, they have just ejected all the surrounding matter that was providing the necessary friction. With the core swept clean, how do they bridge the final gap? How do they shed the last remnants of their energy to finally become one? The answer lies in one of the most astonishing, deeply poetic predictions of Einstein's general relativity. To lose their final, immense reserves of energy, the black holes do not interact with matter. They interact directly with the fundamental fabric of reality itself. They radiate gravitational waves. To understand this phenomenon, we must remember that spacetime is not a rigid, empty void. It is a pliant, four-dimensional manifold, possessing a stiff, heavy elasticity. When massive objects accelerate, they create physical ripples in this fabric. Much like a stone thrown into a quiet, still pond creates expanding ripples of water. For ordinary celestial objects like planets or small stars, these ripples are so infinitesimally weak, they are entirely meaningless. But when two supermassive black holes, possessing the most extreme concentrations of mass in the universe, orbit one another at a significant fraction of the speed of light, they turn the fabric of spacetime with unimaginable violence. They generate powerful, rolling waves of gravity that radiate outward in all directions, traveling precisely at the speed of light. These are not waves of energy moving through space, they are waves of space itself. If you were suspended closely enough to witness this invisible phenomenon, floating in the empty dark, near the binary pair, you would not see a flash of light or hear a sound. But as a gravitational wave passed through you, the actual physical space you occupy would be momentarily distorted. You would be stretched vertically and compressed laterally, and then stretched laterally and compressed vertically, in a rhythmic, undulating distortion of your very geometry. The universe itself is breathing, expanding and contracting in the wake of the earth, and the wake of the lyre. And these gravitational waves carry immense amounts of energy away from the binary system out into the deep cosmos. Because energy is leaving the system, the orbit of the black holes must shrink. The mechanism of decay has resumed. As they draw closer, their orbital velocity increases, which in turn causes them to emit even stronger, more frequent gravitational waves. It is a compounding, inescapable feedback loop. This final, accelerating phase is known as the inspiral. The two spheres of absolute darkness begin to blur. They circle each other 100 times a year, then 100 times a day, then 100 times a second. The velocity at which they travel approaches 99% the speed of light. The fabric of the universe between them is twisted, stretched, and folded to its absolute breaking point. The emission of gravitational waves becomes a roaring, invisible torrent, pouring more raw power into the vacuum in a single second than is generated by the combined light of every single star in the entire observable universe. It is completely, perfectly dark. It is a silent cataclysm. Finally, the exact mathematical boundaries of their event are Eisen's touch. The geometry of the universe strains, yields, and violently restructures itself. The two spheres merge, flowing into one another like heavy droplets of black mercury. In this infinitesimal fraction of a millisecond, the final, supreme peak of gravitational energy is released. The singular, merged entity undergoes a process known as the ring down. The newly born, unbelievably massive black hole is initially misshapen, distorted by the violence of the collision. It wobbles, ringing like a struck cosmic bell, shedding its final imperfections into the fabric of spacetime through a last, fading sequence of gravitational waves. The ringing stops, the geometry settles. What remains is a single, perfect, flawless sphere of darkness. It is heavier, wider, and deeper than the two that preceded it. The surrounding space, having endured the most violent localized event possible under the laws of physics, returns to a state of absolute flat calm. The gravitational waves have passed, rippling outward to the very edges of the cosmos, carrying the silent news of the murder to distant, unhearing galaxies. In the heart of the new elliptical galaxy, a profound silence reigns once more. The newly forged Leviathans, it's alone in the hollow core it carved for itself. It has consumed its rival. It has woven two tiers in reality into one. It will now settle into a state of quiescence, an ancient, brooding monument waiting out the long, slow death of the Stelliferous era, patiently waiting for the trillions of years to pass until it too will eventually begin to evaporate. As the echoes of this invisible collision fade away into the deep dark, we are left with a profound realization about the true nature of the objects we have spent the night exploring. Black holes are not simply engines of destruction, nor are they mere mathematical anomalies. They are the supreme sculptors of reality. We must now prepare to synthesize everything we have learned, moving toward our final reflection on the nature of time, gravity, and the quiet beauty of the absolute unknown. We turn, finally, to the philosophical horizon. We have traveled an immense and unfathomable distance tonight. We have drifted far beyond the comforting, scattered light of our local constellation, slipping past the chaotic, blinding accretion disks, and traversing the mathematical boundaries where reality itself fundamentally alters its behavior. We have witnessed the tearing apart of solid matter, the slowing unfreezing of time, and the violent, invisible collisions that send ripples through the very fabric of the cosmos. Now, as our journey nears its inevitable conclusion, we must pull back from the mechanics of the abyss. We must synthesize this vast, complex architecture and consider the profound philosophical implications these dark monuments hold for our understanding of the universe and our quiet place within it. When we observe the anatomy of a black hole, we are not merely looking at an object of destruction. We are looking at the absolute limits of the physical world. Black holes force us to confront the uncomfortable, yet deeply beautiful truth that human intuition is an incredibly narrow lens. We evolved to understand the slow physics of a small, rocky planet. We inherently believe that space is a fixed, empty stage, and that time is an unyielding, ticking clock, pushing us relentlessly forward in a straight, irreversible line. But out here, in the heavy dark, the universe reveals a different, far more elegant truth. Gravity is not a magnetic tether pulling matter through an empty room. Gravity is the shape of the room itself. The geometry of the cosmos dictates the flow of time and the paths of light. This realization is profoundly freeing. It means that the rigid ticking clocks that govern our waking anxieties, the schedules, the deadlines, the rushing minutes of the day are ultimately just local illusions. They are fragile constructs that lose all meaning in the wider, cosmic ocean. Think back to the glowing probe we watched fall toward the event horizon, suspended forever in a state of perfectly frozen time. From the perspective of the wider universe, that moment is eternal. The present is not a universal constant. It is a highly subjective, malleable experience. What is a fleeting, panicked fraction of a second to one observer is a calm, infinite eternity to another. When the weight of your daily life feels too heavy, when time feels as though it is moving too fast, remember the quiet ghosts trapped in the temporal amber of the horizon. Remember that time can be stretched, slowed, and entirely halted. There is a deep, architectural patience built into the foundation of reality. Beyond the illusion of time, there is the profound mystery of information. We observed how the extreme tidal forces meticulously deconstruct physical matter, stripping away its chemistry, its structure, and its history. But the theoretical physics of the horizon suggest a beautiful, almost poetic compensation. The holographic principle, one of the most advanced and esoteric concepts in modern cosmology, proposes that the defining information of everything that falls into the darkness is not lost. It is perfectly mathematically encoded onto the two-dimensional surface of the event horizon itself. If this principle holds true, it means a black hole is the ultimate, silent archivist of the universe. It is a cosmic vault. Every dying star, every wandering photon that has ever crossed the threshold is remembered, its essential data flattened and preserved on the boundary between the known and the unknown. This implies that the universe possesses a fundamental, unbreakable memory. Even in the face of absolute, overwhelming gravity, the essence of what once existed is never truly erased. It is simply translated into a language we do not yet understand. It is this age of understanding that offers the greatest comfort of all. We live in an era where humanity is desperate for absolute certainty. We strive to measure, categorize, and solve every anomaly we encounter. We want the universe to be a neat, solvable equation, but the black hole, and specifically the blinding, infinite mathematics of the singularity, stands as a quiet monument to the unknown. It is a coordinate where the master theories of general relativity and quantum mechanics shatter against one another. It is a locked door that our current mathematics cannot open. And there is a profound, resting peace in that feeling. The universe is vast enough, complex enough, and ancient enough to hold secrets that we are not required to understand. We do not need to carry the burden of universal comprehension. We can simply observe the beautiful, terrifying mechanics of the void, acknowledge our own smallness, and find comfort in the fact that the cosmos will continue its majestic, unbroken choreography, whether we solve its equations or not. As we drift slowly back toward the familiar, glowing arms of the Milky Way, we must bring this vast, crushing scale back down to the quiet space where you are resting. The unfathomable forces we have explored tonight, the crushing gravity, the nuclear fires of the massive stars, the microscopic quantum fluctuations, they are not isolated, distant phenomena. They are the very same forces that altered your existence. Every single atom of heavy matter in your body, the iron circulating silently through your bloodstream, the calcium fortifying your bones, the carbon forming the complex, delicate architecture of your cells, all it was forged in the unimaginably hot, crushing cores of ancient, massive stars. The stars that lived short, violent lives. The stars that ultimately lost their battle against gravity, collapsing inward and blasting their enriched outer layers across the interstellar void in a blinding supernova, leaving only the dark, silent black holes behind. You are made of the debris that escaped the abyss. You are the universe, observing itself, formed from the ash of the very Leviathaness we have just studied. The same quiet, ancient physics that governs the slow evaporation of a supermassive black hole in the deep, freezing future is the exact same physics that quietly regulates the slow, steady beating of your heart right now. There is no separation between you and the deep dark. You are an extension of the cosmic geometry. Let that ancient, universal connection settle into your mind as the night deepens. Let the vast, empty distances between the galaxies put the small, localized weights of your day into their proper perspective. The universe is entirely unhurried. It operates on temescals of billions and trillions of years. It feels no urgency. It harbors no anxiety. It simply exists, breathing inward and outward through the slow, silent warping of space and time. It is time now to mirror that cosmic surrender. Just as a star eventually exhausts its fuel and surrenders its mass to the gentle, inevitable pull of gravity, you can now exhaust the racing thoughts of the day and surrender to the quiet, inevitable pull of sleep. There is no need to struggle against the dark. The dark is not empty, and it is not malicious. As we have seen, the absolute darkness is merely a place of perfect stillness, a coordinate where time slows down to a gentle, eternal halt. Allow your breathing to deepen, mimicking the slow, rhythmic pulsing of the gravitational waves rippling through the void. With every exhalation, imagine shedding a layer of tension, letting it drift away from you like the cold interstellar gas, swept outward by the stellar winds. Let the muscles in your physical frame soften, yielding to the gravity of the planet beneath you, trusting that you are anchored securely in the center of your own quiet space. Your mind has traversed the extreme edges of reality tonight. It has worked hard to conceptualize the infinite density of the singularity, the temporal illusions of the horizon, and the microscopic leakage of quantum radiation. It has earned its rest. You can let the complex mathematics dissolve. You can let the immense, crushing scales fade away. You no longer need to hold the architecture of the cosmos in your thoughts. For one final moment, the perfect, unyielding sphere of the event horizon, suspended silently against a backdrop of distant, ancient stars. It is the ultimate symbol of quiet permanence. Nothing is required of it. It simply rests in the fabric of space-time, a monument of stillness in a restless universe. Let your consciousness drift toward that quiet sphere. Do not fear the crossing of the threshold. Let your awareness slip gently past the boundary of the waking world, moving into the deep, sequestered interior of sleep, where time no longer matters, where the physical world is entirely left behind, and where the mind can finally dissolve into a state of absolute, peaceful rest. The universe will continue its slow, majestic turning while you are gone. The stars will burn. The galaxies will drift, and the silent watchers in the dark will keep their heavy, eternal vigil. Everything is exactly as it should be. The mechanics of the cosmos are flawless. You are grounded, and you are entirely free to let go. Thank you for joining me tonight on this journey to the edges of understanding. From the deep silence of the void, this is the Sleepy Phantom, wishing you a profoundly peaceful night and a beautiful endless sleep.